All right, guys. So welcome back from the Zoom interruption. And as we were saying, we're trying to find the length of PB. We're trying to find the bearings of PB from the north line of P. And we have already gone through working out the length of this right angle triangle constructed to PB by finding the sides of the smaller right angle triangle. Then we would sum these smaller sides to get the length of the larger sides. So here we know the length of the base, which is 10.732. We know the height of the triangle, which is 6.566. And we are using Pythagoras' theorem that will give us the length of PB. So we use PB squared is equal to PF squared plus BH squared. And so we already calculated those lengths, so we just put those lengths in, which is 10.732 squared plus 6.566 squared. Do those calculations. So we see that PB squared equal to 158.3. We find the square root of that. We'll see that the length of PB is 12.58 kilometers. All right, guys, so we would have found that length. So that is part, we would consider that is the first part of the question. So the second part of the question now would be to find the bearings of PB from the north line at P. So now that we know what that length PB is, the question now, can we find the bearing, which is theta? So now looking at this, guys, how can we calculate that angle of theta based on what we have here? All right, anybody with any suggestion, feel free to give some suggestion to answer this question. So I'll give you about 3 minutes to think about it, and then we can go through it together. All right, Ms. Wesam, do you have an idea you want to share with us?
No, sir. I was wondering, sir, how you got 12.58 for PB?
All right, because when we apply Pythagoras theorem, we would have squared 732. And then we would have squared 6.566. And then we add them, then we would have found the square root of that.
Oh, so okay, sir. Let me see what me get me go around now. All right, sir, thanks.
All right, so anything to offer in terms of this angle here? Anybody?
Which angle, sir?
The angle theta, that's the bearings that we're trying to calculate now. Remember that this is the second part of the question.
Oh.
Anybody with any idea? All right, I'll still let you think.
Sir,
Yes, go
is
ahead.
is it the same little angle between 70 and 20?
No, that's not the same.
Oh, a different one. Oh.
That is what we're trying to calculate. That's the bearings that we're trying to calculate. But we are using what we know from what we calculated for the length of this big triangle. So we calculated PB, we had calculated PF, we had calculated BF. So the question now, can we use anything from this to work out the angle theta, which is the bearings? That's what we want to find. So think about it, guys, and raise your hand and let me know when you come up with an answer. Anybody? Anybody came up with any brilliant idea? Let's wait some. Anything out of your brilliant box of ideas? Miss Darty, what about you? Mr. Lamar? Miss Green? Any ideas?
Sir, I was thinking if you add you add all the side, like you have an idea of the hypotenuse and you have an idea of PB.
You continue, Darty?
Sorry, if you add, sorry, I was thinking if you add all the side and then you minus it from the 90-degree angle.
That wouldn't really help with Darty because you adding the sides would not give you an angle within the triangle. So what you may want to do is to see if you can find an angle within the triangle using what you know about the sides and the trig ratio. Mr. Lamar, were you saying something?
Is it possible to find out an angle in a triangle by using the length of the lines?
Of course, that's the purpose of the ratio. Remember that the trig ratios that you learned, that's one thing that you can do. You can use sides based on ratios to find angle too as well. You have done that already.
Sir, can I get 3 more minutes?
All right, take 3 more minutes. Ms. Wilson, may I have something to add?
Sir, I don't know if it makes sense, but I'm looking at this because I remember one time the teacher something like about reverse mirror business with the two right angle triangle, one reflecting. So I was saying
that's a brilliant idea. So we talk about Z angle. So this angle,
right, yes, sir,
would also be
right.
theta. Good thinking.
Yes, sir. But so sir, me look on this, but basically form one X triangle from the north line going up there, and then that basically flip. You know, the adjacent same would have been 6.566, and then the base would have been that, and then you'd have the opposite, then you would say angle theta, so you'd have the what is that be what opposite over adjacent.
So you would be
one of the
what you want to do, you want to calculate angle theta?
Or well, yes, right. That is it, sir. So it would have been the opposite, which is a 10.732 over the 6.566.
Right. So you could use which trig ratio you want to use. You have
opposite over adjacent would have been the tan.
Right.
Tan ratio.
Can you use any other ratio apart from the tan?
Oh, no, sorry, may I look?
But you also know the hypotenuse, you know?
Oh, mm-hmm.
Adjacent. So in fact, you can use any of the three trig ratios.
Yeah. Yes.
So which one you want to work with? That's the question.
We can use the sine as well, sir, because that would be the opposite over the hypotenuse as well.
So you tell me what to do then, Miss Waysam.
So sine theta, sir.
So you're using sine theta equal to
10.732 over 12.58. Sir, and then let me tell you what that would equal to, sir.
Work out to be what now?
10 point, hold on, sir. 732 divided by 12.58 would equal. How many decimal points you need, sir? 2 or 3?
At least 3.
0.853.
0.853. You round it off correctly.
Yeah, it would be 853, sir.
All right. Now you want theta would be
right. So it would be the sine inverse.
Sine inverse, correct.
Yes, sir. Of 0.853.
The sine inverse.
So, that would equal to 58 point oh, it's an angle, so it would run off to number 59 degrees, sir.
All right, so you said 59 degrees. That is almost 60. All right, 59.
Yes, sir.
All right. Anybody else had any other idea that they would want to share? That's not the only way to get to that angle, because you could also use the same triangle to calculate this angle here too as well, if you wanted to find this angle. And then you could subtract this from 90 to get this angle here. Because you know that alpha plus theta would give you 90. So if you find alpha, you could subtract it from 90. And you get theta. All right, good, great job, Ms. Wilson. All right, so let me just clear this and just walk you through the process. So this is one other way you could find that angle, which is the angle BPF, which is what we would refer to as alpha. And that would be 31. You could now subtract that from 90, you will get 58.5, which is the same as 59 if you round it off, all right? All right, so whichever way approach you take, you would still get the same answer, right, Ms. Waysam?
Yes, sir.
All right, right, Ms. Doherty?
Yes, sir.
Right, Mr. Lamar?
Yes, sir.
Yes. Ms. Green?
Sir.
Yes, so you guys good with what we have done so far. Now, this question is rather long and a little tedious. Don't get too weary about questions like these. If CSEC give you any of this question, or a question this challenging, it would be, well, it is not very likely that you'll come across a question like this. A question that you will get from CSEC would be a little less challenging in terms of the time that you have to work out these questions. They wouldn't put one like this on the paper. But this is a good question for practice because it helps you to apply all that you know in terms of trigonometry, Pythagoras, and so on. So it's a good question to practice. All right, so I would suggest that you could watch back the video or you could go through the slides and walk back through this question for practice, guys, all right? And so we are going to be ending the session right here. We're going to be ending quite a little bit earlier tonight. All right, so stop sharing.